Hey guys, this is Mrs. Harbin, and we are moving into section 5.5, which is all about identities, specifically trig identities. Now, this is going to combine what we learned earlier this year about the trig ratios with geometric proofs. And if you're not super confident in your geometry or your proof or reasoning skills, then this lesson might be a bit of a challenge for you. Hopefully, we'll break it down step by step so that you finish the lesson feeling confident in your understanding of trig identities and trig ratios and geometric reasoning. Make sure that you write down any questions that you have so that you can ask me next class. Our biblical integration for this chapter is that God allows us to have challenges in life, but He also equips us to face them. Becoming familiar with useful terms is like putting on armor to face algebraic problems. And as we get into this unit, Unit 5, you guys have definitely faced some challenges where we've had to go back and clarify some understanding and build up some foundational skills in logarithms and exponents. And we'll do the same here with our trig identities. But using this, gaining this foundational information, if you will help us when we want to tackle more challenging problems in the future of this class and then moving forward into calculus. Our lesson objective for today is that you, the student, will recognize identities as a special type of equation. That should say identities here. That should be a T. You will state the reciprocal and Pythagorean identities and prove trigonometric identities. All right, so not too difficult here. We're going to recognize something. We're going to state a definition of something, and then we're going to prove. The hardest part of this will be the proving, because that's going to be where you apply the reciprocal and Pythagorean identities and some other identities that you've learned throughout the years in school. So that will be the most difficult of what we do today. Let's talk really quickly about what an identity is, since our first objective was to recognize or define an identity. An identity is an equation that is true for all values in the domain of the variable. And you've learned lots of identities already. For example, you know that x to the 0 power equals 1. For all values in the domain, it doesn't matter what we plug in here in our domain and our x values, we're always going to get 1. Anything to the 0 power is 1. You've learned, for example, that x times 0 is 0. That 0 property product, okay, that 0 identity. That's true for all values in the domain. No matter what we plug into x, those identities are true. So an identity is an equation that is true for all values in the domain. When these identities were first discovered, if you will, they had to be proved before they were accepted as being true. Identities are no different. They had to have been proven, and they continue to be proven over and over and over again. And we're going to look at some of those identities. An equation that is not an identity is called a conditional equation. So we have identities and we have conditional equations. And like I just said, identities have to be proved before they can be accepted as true. After an identity is proved, it can be used then to prove other identities. So once we, for example, discovered that x times 0 is always 0, once that identity was proven to be true, we can use that identity to prove other things. And in geometry, you learned all different types of identities to prove things in geometry. If you didn't quite learn those, or if you're not so sure of what you learn or what you remember, we'll see some of those same identities again today in the proofs that we do today. Now, the proofs that we are going to do today are centered around trig ratios. And so it's really important that you know the definitions of the trig ratios, because these are going to provide the foundation for what we are doing today. So just as a quick reminder, we get our trig ratios using these acronyms. Sine is opposite over hypotenuse, so that's so here. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle is opposite over hypotenuse. And we have done a whole lot of work with these trig ratios. We can use trig ratios to find the side lengths, missing sides of the triangles. We can use it to determine an angle measure in degrees and in radians. We use it for a lot of different information. So it's really important that we know these three basic trig ratios. If we're putting this in the context of the Cartesian plane and we draw ourselves a right triangle here, remember, trig ratios only do apply to right triangles. You can see that this is our x value. This is the x-axis here. And this right here is our y value. It's our vertical value. And our radius is right here. And in the unit circle, we said our radius was always 1. So when we're talking about trig values or trig identities, we're going to apply everything to that unit circle where our radius is always 1, because 1 is an easy number to work with. That makes sense. But you can see sine is opposite over hypotenuse. In this case, here's our angle. Sine is y over r, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent's right here, so x over r, x over the radius. And tangent is opposite over adjacent, which is our y value over our x value. And all right triangles have these ratios in them, which makes working with right triangles super important and super helpful. So we need to know these trig ratios. We are going to come back to this a little bit later right here. This is going to be the foundation of our Pythagorean identity. Now, I'm going to mention it briefly and then we'll come back to it. If you remember, we said the Pythagorean theorem, or the Pythagorean identity, was a squared plus b squared equals c squared. So we basically take the two legs of our triangle, so leg 1 squared and leg 2 squared, and that is equal to our hypotenuse squared. If you struggle with A, B, and C, remembering what's what, remember that it's the two legs, the two sides of the triangle that form the right angle. Those are our legs. And the hypotenuse is the longer side across from the right angle there. So we know that this is true. It has been proven countless numbers of ways that this is an identity, the Pythagorean identity. Well, using the letters that we have over here, x, y, and radius, we could just substitute in and say that x squared plus y squared equals our radius squared. Okay, so you see that one right here. X squared plus y squared equals our radius squared. That's this first one right here. We can rewrite that in different ways. Let's say we wanted to solve that in terms of x. Well, to solve that for x, we would have to subtract, right? So we get x squared equals r squared minus y squared, right? You see that form right there, that version, the exact same identity, just written a different way. Or if we wanted to solve for y, then we would have y squared equals r squared minus x squared. Right here, there we go. So these are all the Pythagorean theorem, the Pythagorean identity. They're just written in 3 different ways. Once in terms of the radius or the hypotenuse, once in terms of x, and once in terms of y. And this is going to be important when we talk about the Pythagorean identities in terms of trig ratios here. So keep this picture in mind. You may have to flip back to it and look at it if you need to. We're at 7 minutes and 45 seconds if you need to come back to this picture. All right, the first identities that we're going to talk about in terms of our trig ratios are actually called the reciprocal identities. And the reciprocal identities state that 1 over cosine, or the reciprocal of cosine, is secant. The reciprocal of sine, or 1 over sine, is cosecant. And the reciprocal of tangent, or 1 over tangent, is cotangent. Okay, conversely, if these are true, then cosine must be equal to 1 over secant. And sine must be equal to 1 over cosecant, because they are reciprocals of each other. And tangent must be equal to 1 over cotangent. So these are the 6 trig ratios, or trig functions that you need to be familiar with. Sine, cosine, and tangent, you should be very familiar with by now. And then secant, cosecant, and cotangent. And you do need to recognize that these are reciprocal functions. Now, if you want to see the proof of why these are true, you can look on page 247 of your book. And these are worked out for you in proofs so that you can see why these are true, if you wanted to know that. The Pythagorean identity is the second type of identity that we need to commit to memory. And they are based on the equation that we already looked at. X squared plus y squared equals r squared. So going back to our unit circle here, okay, we've got our radius, which is going to be equal to 1, and then our x and our y values. Okay, remember, this is how we determine our sine and cosine. I'm going to try and still here. If you remember on our unit circle, this point right here, we actually can label as cosine and sine. The cosine and sine of this angle will help me find this value, because cosine is x and sine is y. So keep all of that in mind, and our radius is 1. So the Pythagorean identities are based on that equation. X squared plus y squared equals r squared. We know that cosine is x, so we can write that as cosine squared theta. Our y value is our sine value, so that's sine squared theta. And our radius squared, our radius in a unit circle, is just 1. So our first Pythagorean identity is this. Cosine squared theta plus sine squared theta equals 1. And you can see that hopefully from the unit circle, you can tell where that's derived. Well, we can write that a couple of different ways. If we wanted to solve for cosine, for example, we could write cosine squared theta is 1 minus sine theta, or sine squared theta is 1 minus cosine squared theta. We can just rewrite that in different ways. And we also know then that tangent squared theta plus 1 equals secant squared theta. Again, if you want to see this worked out, if you want to see this proven, you can look on page 248 and you can see the proofs for these. And we can rewrite that to where it would say tangent squared theta minus secant squared theta equals -1, or we could solve for tangent squared theta equals secant squared theta minus 1. So we could rewrite that, 3 different ways there. And our final Pythagorean identity is 1 plus cotangent squared theta equals cosecant squared theta. Again, we could rewrite that a couple of different ways where we solve for cotangent squared theta equals cosecant squared theta minus 1. Or 1 equals cosecant squared theta minus cotangent squared theta. So each of these trig identities, not only do you need to memorize this one that's apparent right here, but you also need to be aware that these can be written in different ways depending on how you're writing it, what you're writing it in terms of. If you're writing it in terms of cosine, or in terms of tangent, or in terms of cotangent. So you can see here that all of my trig identities, all my trig functions are represented. Sine, cosine, tangent, secant, cosecant, and cotangent. All of them are represented. So whenever you are dealing with a function or an equation or a proof, and you've got a trig value that's been squared, and you've got a 1, you really need to be thinking, oh, I bet this is a Pythagorean identity. All right, so we know our reciprocal identities, and we can see, and we're going to learn and memorize our Pythagorean identities. Now let's talk about how we can use that to prove identities. I'm going to go through the steps in this video, part 1, and then part 2 will actually work through proving some identities. So when proving identities, the first thing that you are going to be given is an equation. One thing is equal to something else, and you're being asked to prove that that is in fact true. When you do that, you want to choose one side of the statement that you are going to prove. So you're going to start with 1, and you're going to follow some mathematical steps to try and get it to look like the other half, look like the other side. So we want to choose one side to start with, and that's the side we're going to set out to prove. We're usually going to start with the more complicated side and try to prove it and rewrite it so that it looks like the simpler side. We'll use basic definitions, algebra, and previously proven identities to simplify the chosen expression so that it matches the other side. We're trying to get that rewritten in a way so that both sides look the same. If we're unable to simplify one side to look like the other side, we may have to work on each side separately on scratch paper to see if there's a relationship between the two. Start from the bottom and work our way up, start from the top and work our way down, see if we can find some kind of connection. If you've ever played the game 6 Degrees of Separation, it's this idea that every person in the world is only 6 relationships away from everybody else in the world. That, I might know this person who knows this person who knows this person, that we can all be connected in 6 degrees or less. Trig identities and proving these identities are kind of like that sometimes. You're not sure how the two are connected, and you've got to kind of work to find what the relationship is between them. So you'll see that when we go through some examples. We don't want to use properties of equality. So we don't just want to say 2 plus 2 equals 4. Okay? We want to use other definitions and identities. If we find an identity that's extremely difficult to prove, then we need to change each member to its basic trig ratio, definition, and simplify. So if we just are stuck and we can't figure out what to do, but we would change each to its basic ratio. And again, I'll show you that when we work through some problems, and then try to simplify from there. If we still cannot prove the identity after all of these steps, we want to try some number values in the equation and see if we can find a counterexample to show that this identity is false. All right, so that's what we're going to do. Part 2 of this video will take a look at some actual proofs that we will work through together.